All right, so in this next one, we have a new concept called conservation of energy. And what that tells us is that energy shouldn't be created or destroyed, it should just be converted from one type to another. And so, I made a brief mention of this earlier. That if we have an object that can fall, then it has some kind of potential. And then when it starts to fall, it's using that potential. So it's losing the potential and it's gaining kinetic energy. So it swaps from one type to the other. You know this, you hold something high up in the air, let it go. It has potential before you let it go. It's using that, and then it speeds up. And then the fastest point is right before it hits the ground. So what we can do with this is whatever change in kinetic energy we have is going to come from whatever change in potential energy we had. And that means that we can take our formulas and we can set them equal to each other, right? So our kinetic formula, we had 1/2 mass times velocity squared. And the potential energy, we have mass times gravity times height. Now, the nice thing here is that mass can cancel from either side. And as it turns out, it doesn't matter what the mass is for any object, it should work the same way. Um, let's see, what are we trying to find here? Find the distance, so we want to find h. Okay, so using the simplification here and kind of swapping sides to make it line up a little bit better, we've got gravity times height, and again, I'll just swap that from over here. 1/2 of v squared is the same thing as v squared divided by 2. And that's kind of convenient because now when we go to finish solving for the height here, we can divide by gravity and divide by gravity and sort of consolidate a little bit. So the more concise version of this formula, v squared over 2 times gravity. Now, technically, you can do a little bit better there because if you remember that gravity is always a certain number, then obviously doubling gravity will always be the same certain number. And using that to our advantage, we can say that the height is equal to the velocity squared over double gravity. So we have 9.8 turns into 19.6. Power 6. There we go. Technically, meters per second squared. So we can think of this as being like a constant where we only need to plug in one number. A little bit streamlined process. It's up to you how you do it. If we've gotten to here, though, then we really don't have much left to solve. 1894 meters per second squared, so squared from the formula, 1894 from over here, then divided by twice gravity, which again was 19.6. It may seem like the units are going to cancel, but you've got to be careful. On the top, the meters and the seconds get squared, both of them. And so that's going to cancel all of this. But then overall, one of these m's goes uncanceled. And that's where the meters for distance come from. All right, so long story short, we finally have everything we need. The units are picked out. We see where they're going to go. Take 1894, multiply by itself, then divide by 19.6, and overall about 18.3.